signal flow graph. Here also we are going to determine the transfer function. There will be a flow of signal, okay, with an input C. Sorry, with an input R, okay, and the output is taken as C. So transfer function, what is the formula? The ratio of the Laplace transform of output to the Laplace transform of input. Okay, so the transfer function is what I said. C is the output. There is a, which means there will be a flow of signal. Okay, so there will be a flow of signal. Here R will be the input, C will be the output. So Laplace transform is output to the input. That is C of S by R is we have to find out. Okay, so for that what we are going to use is we are going to use the Mason's formula. We will be saying it as Mason's gain formula. Can be asked in 2 marks also. Okay, so Mason's gain formula what it means the overall gain. I said this is a signal. This is a flow of signal, right? We have to calculate the overall gain. That is the overall gain is to be the transfer function. That is transfer function V of x is equal to the formula is 1 by the summation of k is equal to 1 to up to maximum number of values. And then Pk del k. Okay, here the Pf is the transfer function. We already know that. Okay, and Pk is what? It is a forward path up to k value. When solving the problem, you will come to know what is the k value, what is the forward path and all that. Okay, and the del is the formula as 1 minus sum of individual loop gain. Okay, and then if you notice that is 1 minus. Clear? Next one it is plus. Okay, that is alternate both sides. 1 minus sum of individual loop gain plus sum of gain divided of all possible combinations of two non-touching loop we have to check. Okay, and next again minus. Okay, alternative side 1 minus plus minus like that. The minus after that what happens is it will go for sum of gain divided of all possible three non-touching loops. Okay, so there will be flow of signals. First we need to look out the forward path. Next we have to look out how many individual loops are there. Next we have to look out in that particular loop how many two non-touching loops are there. After that we have to look out the how many three non-touching loops are there. After solving, after finding out one by one, we will be substituting the gain minus gain formula. Okay, then we will be getting out the transfer function. That is the concept. For doing this, either signal is given as a straight line, a signal flow graph, if it can be given as like this. Okay, if not, it can be given as a block diagram. You know the block diagram. Last we have seen block diagram as a set. The input first it will be given into a summing point. It is like this. Okay, and again this given to a block, and the name of the block is called G. And again it is given to the one more summing point. It is plus. Okay, or else here it is plus. And here the output. Now what is output I have told you? C. That is C of S. What is the input I have told you? That is R of S. Okay, and here from here what we are doing is I am going to take a node over. What is this node then? This node is the point where one branch gets divided. Okay, so here is our question. What happening? Here a node gets divided. Okay, again here will be a block and if it is joined. Okay, all this is said to be what? Forward path. Okay, everything is goes from input node to output. Input node means what? The node where the input is just released or applied. Okay, that is the input. Now output node is what? Only the entire system flow will come to an entire node point that is simply output node point. And this joint junction of branch point node is node. Okay, so from here if it is here it is I have marked as G1, if it is G2. Okay, and again if I am getting the marking this here and I am getting a feedback over here from this side. What is the feedback representation? H. So the feedback representation is H over here and it is given to where? Minus. This is a basic block diagram we know. Okay, so if it is for block diagram reduction, you will be using the block diagram reduction technique. If the question is asked like this, in a filter which is represented as a single flow graph, find out the overall gain of the filter. it is asked like this, and the question is given in blocks means what we have to do. First, we have to convert this block into signal flow graph. What we have to do? Convert the block diagram into signal flow graph. Okay. How will we convert it? First, we have to load on the first. That is our input load. Next, can you take this as one? Okay. So what I am doing? I am going to take this as one. Okay. And from here, what is this here? Next, what comes?
G.
Shall we take this as 2? Okay. So I am going to take this as 2. Okay. And so on the here also you can only 1, can be 2. Okay. And likewise, summing point can be 3 and this point can be 4. We can take like that. So what I am doing? Summing point is 1. The point has 2. Okay. And what we are going to again the summing point is as 3. And again there is a feedback node that is as 4. And this is our CFS. First we have to understand. Next we have to look after the signal where it is from where it goes. Okay. So from 1. Okay. From 1 where the signal comes from 4. Okay. What does the point over here? Plus minus. Okay. So this plus minus means you have to multiply with what? Minus 1. Plus minus 2, automatically there is a minus. So what will we doing? So here comes 2 comes here, achieve to minus 10, achieve to minus 1, which means minus x. Correct? So from where it comes? From 4 to 1. Okay, you have to put the, don't need to put the block diagrams on that, just the signal. 4 to 1, you have to multiply with minus 1 means it will become what? Minus h. So from 4 to 1 comes minus h. Clear after this? And next, from node 2. From node 2 to where it goes?
3.
Node 3. Who comes here? G2. Notice the summing point over here? Plus. Which means we have to multiply with just 1. Okay, from node 2 to node 3. Okay, that is forward part. Here this means G or Z forward part. The H is for feedback, that is, it will go this direction, right? So we have drawn arrow over here and we have marked it as minus H. Okay, and here it is plus plus and it is forward part. I have marked the arrow here and who goes there, the block the system is G2. Up to here. We are clear? And now wherever the here is an input, that is RFS. Okay, and from 2 to 3, right? 2 to 3, one more thing is going over here. What it is?
G1.
That is in the straight path. Here it is a loop path, and here it is a forward path over here. And what it is?
G1.
G1. And then from 3 to 4 is there anything? No, just forward path. That's it. Okay, that's all. This is how we have to convert the block diagram into a signal flow graph. Okay. After that, we have to solve according to how we will be solving the signal flow graph. First LLP given in the small components. Okay. First, we have to look at the forward path. That is the first step. Okay. How many forward paths here? From here, and one more thing you have to notice that here it is from 1 to 2, 2 to 3, 3 to 4. Right? So here there is no signal, right? This point is negative 1, this is 2, this is 3, this is 4. From 2 to 3 there is G1, right? And after 1 to forward path that is G2, right? And from 1 to 2 is there anything as mentioned in it? So you have to take it as 1. Okay. And 3 to 4 is there anything mentioned here? So you also have to take it as 1. And from R to here is also 1. And if it is not mentioned also no problem, and you don't need to confuse it is 1. Okay, but these things have to be mentioned. Here only the node things that is multiplied with 1 that you have to mention. Okay. So for solving the signal flow graph, for the first step, what you have to look at I told you to look at the forward path. How many forward paths is here? From the input to straight output, that is this. This line is a forward path. Right? So one more forward path, that is
2, 3.
it will flow from here will go here, right? Am I right? This is also what? Forward. So how many forward paths are there?
Forward.
Okay. So we will be solving that. After that, what we have to look after means we have to look after that. Now I have found out the forward path. Next, what I have to find out how many individual loops are there. Okay. So how many individual loops are there? So first, what is a loop means? Loop means what? To and fro signal flow, right? If it starts from a node and it goes to a particular node and again back to the same node means what it is means this is said to be what? Loop. Okay, that is signal goes from a node and then the same node is said to be what? Loop. So here where are the loops here? So shall I take from 2 to 3? So it is forward. So it will not come to right?
1
So,
to 4.
so 1 to 4 again 4 to 1. This is the loop that we have to do. Okay, and for that we are going to be doing some calculations over there. Okay, after that what we have to do after? Here it is 31 to 20. So we know that if we are solving a bigger problem means we will be having 2 non-touching loops and 3 non-touching loops may also present. Okay, you have to look at that. Non-touching loop means what means if suppose what assume that okay there is further 2 nodes here that is 5, 6. Okay, and when there is a forward path when saying here it is again going to feedback path that is such mentioned as such one. Okay, here it is G4. So it is like this means this is also a loop and this is also what? So starts from a node, goes and back to the same node. This is also loop. If these 2 loops are touching each other, no. So this is the thing. That is sum of the gain product of all possible 2 non-touching loops. Okay. If suppose one more if it is added with 1 more means one more if the signal extends means if that is also a loop means if it is also non-touching means it will stand for 3 non-touching loops. That is how we have to look after the problems. Okay. So this is a problem which is given based on the signal flow graph, and if it is given in a block diagram, it will be like apply the transfer function for the filter or else apply the transfer function for the system in a signal flow graph. Okay. So what we have to do, we have to convert this block diagram to signal flow. So for converting it, we have to base the first node is the nodes. Okay. So there is no signals between this summing point and this node. Okay. So we can consider that as node 1. Okay, and this here there is a signal passing through over there to the summing point. So we will be taking it as node 2. Okay, and next here is a point junction. What it is? Here is a point as feedback over here. Okay, and there is a summing point over the point over here. Okay, so we can take that as the these 3 means as we can take it as 3. Okay, and this node which is a transparent over here, we can take it as 4. Okay, so now after drawing it, how the signal will be? That is 1, 2, how many numbers?
3, 4.
4. Okay, so from 4 to 1. From 4 to 1 there is a feedback, that is minus. So it will be
Minus GS.
minus G5. G5. Okay. Minus G5. Okay. And next from 1 to like this node we have taken 1. From 1 to 3. What is that?
G4 plus G4.
So this thing we can entirely take as 4. Okay. See, all are in the same node, right? There is here everything is 1, 1, 1. So these things we can take it as a single one. Okay. So one thing I forgot to mention, condition is there. Okay. So what is that condition means? Summing point. Okay. Sum is a what? Summing point, right? So the summing point when it is before, okay, when it is before the node, summing point before to this node, it can be taken as a single node. Okay, summing point is before this node, which we can take it as a single node. Summing point after the node. Okay, here is also a node. Here is also a node. Okay, summing point before the node can be taken as a single node.
A single node.
Summing point before the node can be taken as a single node. But summing point after the node can be taken as a separate node. But these two is how separate. Right? Summing point is after. Right? Summing point is after this one. So this should be taken as a conditions that is applied, and summing point is after the junction or as node. So we will be taking it as separate node. So we will be taking it as a separate node. So this point will be 3. And the summing point which is before this node will be taken as 4. Okay, this condition is applied. So for the example which I given for before, that for that also the condition is applied. Okay, so now here, so we can take this as
1, 2.
So this is 1. The input here it is RFS. This node is 1, and here the summing point is 2, and here the node is 3, and the summing point which is before the node is taken as 4, and output is CFS. Now clear? So now from 1 to from 4 to, right? From 4 to
1
minus G5. Since the summing point already minus consider there. Minus G5. And it's from where we are going from?
1 to 4.
1 to 4. We have to mention the arrow of 4. Okay. So here it is what? G4. Since it is plus. Forward. And it's from where it's going? From 3 to 2. From 3 to 2. Arrow is toward this side. Right? Arrow toward this side. So it is what? G3. And from 2 to 3, one more sequence is passing, that is what? Towards the forward part, that is G2. Can you understand? And now, from 1 to 2, who is passing?
G1.
So, when arrow G1 is passing from 1 to 2. Clear? And next, is there any other signal? No. So, from here to 1 end is 1. And here from 4 to the output node is 1. And 3 to 4 is 1. Okay, that's it. And now, can we go for the first step? First, conversion of block diagram into signal flow. This is the first thing we have to do. And next, what we have to do? We have to look at this step. If this question is given straight away, means you are going to do the first step. If the block diagram is given, means this is your first step. So what you are going to do is the second step. What you have to find at first? Forward path. Forward pathing. Okay. What is the forward path over here? From R of S to C of S. There is a straight path over there, right? Which is crossing 1, 2, 3, 4. From here it is 1, and here it is G1, and here it is G2. Again here is a 1. This is one forward path. Okay. What we have to calculate is first you have to draw the forward path. Okay. That is, this is path number 1. So name it as P1. Path number 1. Just what are the signals passing over here? 1 into, you have to multiply. Okay. 1 into G1 into G2 into 1 into 1. So what happens? 1 into G1 into, as I said, this 4 to C1, if it is mentioned as 1 also, not mentioned also, no issues. There it is 1 only. Okay. So 1 into G1 into G2 G2 into 1 is equal to what? G1 into G2. That is forward path 1. Next value of forward path
G4.
from RS to 1 to G4 is the forward path, right? So you have to draw it from RS to 1 to without touching 2 and 3 only this way to 4, right? So you have to draw like this. Clear? In between who it is?
G2,
2, 3.
3.
You don't need to worry about that. But our signal forward path is from RS to 1.
4.
Who goes here?
G4.
G4 to the terminal 4 and
CM.
here is our CM plus. So this is what? Forward path 2. So it will be taken as P2. In multiplication, what are the terms here? Here it is 1, here it is G4 and here it is again 1. Am I right? So we will have to write it as 1 into G4 into 1 and is equal to what? G4. Is there any forward path over there? No. This is the first step you have to find it. Okay. You copy it. First, block diagram is signal photograph. The second step, forward path. Now, third step, what you have to look at means the signal photograph. You have to look after the individual loop. They are that taking loops. Okay. So, from here, which are the individual loops over here?
1 to 4.
1 to
4.
4.
4 to 1.
4 to 1. So let us 1 to 4. 1. In between there is 2.
3.
3. 4 is here. What is the signal from 1 to 4 to 1?
Minus 5.
Minus 5. 1 to 2 plus
G1.
G1 and 2 to 3 is
G2.
G2 and 3 to 4 it is 1. You have to mention all the symbols. Okay. So it is loop 1. Indian textbook or in some other book it will be written as P1. Okay. So for our easy prediction I am writing it as loop 1 L1. Okay. If it is P1 loop you will be get confused because we are taking part of this P1 P2. So just take this as loop 1 L1. Okay. So comes to the multiplication it is G1 into G2 into 1 into minus G5. That is loop 1 is equal to what? Minus G1, G2, G5. Clear? Next, what is equal to loop?
2 to 3.
2 to 3, 3 to 2. Isn't it? So 2 to 3, again 3 to 2. So you have to draw the arrow over there. Okay? This is very important. Okay? And here is the number 2 to 7 is equal to 1 plus G2. And from 3 to 3 plus G3. So this is plus. So let me answer this. That is loop 2. G2 into G3. So we can write this into G3. Clear? And next is there any equal to loop? There only 3 inside. There is no individual loop. 1 to 4. See, this is not a individual. 1 to 4. 4 to 1. Is that a loop or not? Loop, right? So, that is 1 to 4. 4 to 1. That is also a individual. Here goes the signal G4. 1 to 4. Don't need to worry about that. Inside the 3 and all that. This is for your means you can mark this. There is a 2 3 over there. But don't need to mark the signal and don't need to consider option. Just 1 to 4 who is passing G4 and 4 to 1 and who is passing
Minus
G5. And this is the number 3. Okay. So that is completely yes. G4 into minus G5 is equal to minus G4 G9. These are the individual loops. Okay. And now we are calculating for what? Del. Right? So del formula what it is?
1 minus sum of
Minus sum of
individual is going 8 plus sum of Main product of all
I
possible.
have calculated individual loop. This is individual loop take, right? That is L1, L2, L3 are the individual loop take. Okay. Now next what we have to calculate, what is it?
Sum of main product of
all
all
possible
possible
non-touching loops. Now we have to look at the one and two first, and then two and three and one. Okay. So first two loops are found. First loop and second loop. Is it touching with each other?
Yes.
How it is touching? There is a nucleus signal over here, G2 is there. There is also nucleus signal is there, G3 is there. It is touching with each other. Okay. Now see 2 and 3. Okay. 2 and 3, G2 signal is there. Is that 2 and 3? These two are
Non-touching.
non-touching. It is not touching. See. Here it is, the signal 2 to 3 is passive, G2 is there, G3 is there. Here is the anytime 2 to 3 is point forward, but usually I have not. No need to draw that. 2, 3 pointer in left. 1 and 4 multiple. So these two loops are non-touching loops. Okay, so we have to write that as non-touching loops. Okay, so the loop. Okay, write it down. The loop L1 and which one? L3. Or again you have to see the next two. 3 and 1. Okay. 1, 2 we have C. It is not touching with each other. 2, 3 we have C.
Not touching.
It is not touching with each other. Next we have to see with
3 and 1.
3 and 1. 3 and 1 is it touching with each other?
Yes, ma'am.
Yes, it is touching. 1 and 4. Okay. Here is also point 1 and 4. Minus G5 here. This is also minus G5. So it is touching. Touching loop, the non-touching loop is L2 and L3, right? So the touching loops L2 and L3 are
Not touching.
2. We have to write it as 2 non-touching
Loops.
loops. Okay, so what we have to do? L1 into L3. Sorry, L2 into L3. The two non-touching loops is equal to L2 into L3. That is equal to what it is? What is L2? G2 into G3, right? G2 into G3. Next into minus G4 into G5. So overall it is what? Minus G2, G3, G4, G5. Clear up to this? Now all the things we have to substitute to Maxwell's game formula. Okay, the order that is one by one we have to substitute. That is the overall gain. What it is? P of S. That is equal to C of S by R of S. Is equal to what? 1 by del.
1 by del.
First you want to know what is del. First you have to write that del. Del is equal to what?
1 minus
1 minus
sum of gain.
sum of
Individual.
sum of individual locates. What are the individual locates we have column? L1 plus L2 plus L3. Sum of individual locates minus
Sum plus plus.
so we plus
Sum of main product of all possible combination of two non-touching.
right? So two non-touching loop. Okay, so we are taking the name as L2 is non-touching loop, right? So you can take this L substitute loop. Okay, so we can write the two non-touching loop as L2. Is there any other loop non-touching? If it is that, what you have to do? You have to sum of. If 3 and 1 is not touching, then you apply like this. Right? Here it is no, so we have not written this. Okay, so one more thing you have to notice that is there any three non-touching loops? மூணுமே டச் ஆகாம இருக்கா? மூணு லூப் தான் மொத்தமே இருக்கு. இந்த மூணுமே டச் ஆகாம இருக்கா? எப்படியோ என்னாவது ஏதாவது ரெண்டு டச் ஆயிடுச்சு. So three non-touching loop இல்ல. Suppose if it is there, that's what we have to do. Minus of the sum of three non-touching loops in here. Three non-touching loops என்ன பண்ணிட்டோ? Suppose 1, 2, 3 மூணுமே non-touching loops அப்படினா L sufficient for 2 3. நமக்கு இல்லாததுனால அதை இதோட எழுதிக்கலாம் நம்ம ஸ்டாப் பண்ணிக்கலாம். Now substitute. That is 1 minus what is the value 1?
Minus G1 G5
Minus
G1 G2 G5
what is L2?
G2 3 minus
What is
minus
L3?
G4 G5 4 G5 G4
G4
G5
G5.
minus G2 G5 G2 G3 G4 G5 G4 G5
Okay, now let us multiply this minus 4 inside. Okay, so what will become our 9 is equal to 1 minus. It become plus, right? 1 plus G1
G2 G5 minus G2 G3 plus G4 G5 minus G2 G3 G4 G5
G5. Okay, this is our del. And next what it is? Next what we have to summation okay?
summation of
K is equal to 1 to how many common terms are there? 2, right? So you will calculate that Pk del K, right? I will calculate this